If you were alive in 2012, you might have heard of this book, The Fault in Our Stars by John Green, and the one phrase from it that is quoted ad infinitum. Some infinities are bigger than other infinities. Now, I hear what you're thinking. Whoa, hold up. How can one infinity be bigger than another? It's literally infinity. Well, here's the thing. Let's take a look at two infinities and how one is definitely bigger than the other, using a proof by contradiction and a little something called Cantor's diagonal argument. Our first infinity will be the number of natural numbers, and our second, the number of real numbers between 0 and 1. Now let's take every natural number and assign it a random real number in this range. So with this, we're assuming that there are no real numbers left in this range without a natural number to go with. We're assuming that these infinities are equal in size. Now let's build a new number. The first decimal digit of our new number will be the first digit of the first row, 1. The second decimal digit of our new number will be the second digit of the second row, 8. Starting to look a little diagonal? Let's take every decimal digit and add 1 to it. So now we have 0.2970813, and so on. If our initial assumption is correct, then this new number has to be somewhere in our list. But how do we check? Well, we know it's not the first item in the list because the first digit is different. Remember how we added 1? And we know it's not the second item in the list because when we created our new number, we switched the second digit. Okay, but how do we know that there isn't some 634th item in the list that just happens to be 0.2970813, whatever? This number has to be somewhere. Well, it's impossible for it to be the 634th item. Even if the 634th item is extremely similar to our new number, the 634th digit is 1 off. And by that logic, even if everything else matches, our new number is still different from everything else in this list by at least 1 digit. Wait, hold on. So you're saying that this list that contains all the real numbers from 0 to 1 doesn't contain this one? Exactly! This is where our proof by contradiction comes in. We assumed at the start that these two infinities are equal in size. But if that were true, then a list numbered with natural numbers would be able to hold every single real number from 0 to 1. But we just saw how we can create a new number in this range that doesn't exist in the original list. Contradiction! Here, we have a real number, but no natural number to pair it with. We already used them all up in our original list. Therefore, the number of real numbers can't be equal to the number of natural numbers. It has to be strictly greater than. Hence, the infinite set of real numbers is bigger than the infinite set of natural numbers.